Section 2 of Chapter 4 is about metals and alloys. Now, we covered metals in great detail in the last chapter, so I am going to be assuming you know the properties of metals before we continue. Um, let's start at the beginning of time, right? Yeah, in the beginning, or at least the beginning of human time, tools were made out of stone, which is carbon. Again, carbon is the most abundant element on our planet. So what we had available was a stone. I mean, you got a stone, you whacked it over your prey's head, and your prey died, and then you cut it with a stone knife. You've slowly found that other stones were better at this than certain stones. And eventually you found that copper, Cu, and tin could be melted down and combined at a certain ratio and give you an extremely strong tool, which was later to be named as bronze. We do have a whole Stone Age for the age of stone tools, and the Stone Age ended with the Bronze Age. So bronze would take over, and bronze is really our first alloy that was discovered by humans. So we do have bronze weaponry and bronze armor, and you can think of if you were against people who had stone weapons and stone armor, your bronze would simply win out because it was a stronger and more durable material. So that gets into alloys, because that is our first alloy. Alloys are a mixture. They are not chemically bound. They are not compounds. They are not molecules. They are a mixture. I am just throwing two things together and letting them both be themselves. They are not being mixed together. They are made of two or more elements, where one of these elements has to be a metal. And in the end of this mixture, you're going to get a substance, an alloy, that has properties of metals. So again, our first example is copper plus tin equals bronze. So if you can think of it at an atomic level, bronze would be the whole mixture together. Tin is a lot heavier and bigger element than copper is. So if you can imagine that the tin is the bigger molecules or atoms right here, and the copper is kind of seated between them. It's not really in any pattern. They're just kind of mixed together. They will be at a set ratio in order to give certain properties, though. So like 2 elements of carbon for every 3 elements of tin or something like that. I don't know exactly what it is. It's not counted by elements, but you can get the idea. Again, properties of metals are, we looked at these last chapter, they're not really going away, but your properties of metals are also going to be your properties of alloys. So your alloys are going to tend to be strong, they're going to be hard, they're going to be shiny, especially if you polish them up. They tend to have conductivity, which again is heat and electricity. So it conducts heat and it also conducts electricity. Ductility, which is the ability to pull into wires, and malleability, which is the ability to be hammered into sheets. So all these properties are also going to be present in your properties of alloys along with metals. Alloys, however, have the ability to mix different properties of metals and create a solution that is actually going to be different than the original elements. So for example, you probably have some kind of gold jewelry laying around your house, whether it's your mom's wedding ring or something like that. Gold is actually a very soft and malleable metal. I mean, you can sit there and you can squish it around in your hand and form different shapes. It's very soft. However, gold rings are hard because the gold in your wedding ring or whatever jewelry you have laying around that is gold is actually an alloy and not pure gold. Alloys are going to be used to make your pure metals stronger and less reactive to the environment, so they last longer. So if I combined gold with other elements, I get a stronger thing. I still get the shininess of gold, I still get the look of gold, but it is stronger and it's going to be less reactive to the environment, such as air and water. Iron is another example. Iron is going to be very reactive to oxygen. It forms rust. It is not that strong by itself, but you can change the strength of it by making it an alloy. So if I take iron and I mix it with carbon, nickel, and chromium, I actually get what's called stainless steel. And stainless steel has different properties than iron, but it has some of the same. You're going to keep that ruggedness of iron, that durability it comes with it, but you're also not going to get the rusting aspect of it. So you don't get the downfall of whenever I expose this to oxygen, it rusts. And that depends on the actual amount of each of the elements you put into your mixture. So you can make different types of steels. In our next video, we'll talk specifically about steels. But let's talk about making alloys first. There are two ways to do it. One, you can melt your elements down and then mix them together as a liquid in a certain amount. So like 3 cups of iron to 1 cup of steel, or whatever the mixture is, I don't know. But it's at a certain ratio, and there's a recipe you follow for it. This requires a lot of energy because you are changing the state of the actual element. So you do have to go from the solid iron to a liquid iron, which takes a lot of thermal energy to do so. So it does require a lot of energy, and therefore it's going to be a bit more costly. The other way you can do it is by mixing powders and then heating them under pressure to stick them together. This is going to use less energy to create because you don't have to go through that change of state. Basically, we can take a whole bunch of iron, file it down into a powder, take a whole bunch of carbon, file it down into powder, mix the two powders together, then put it under heat and pressure, and push it together with all that pressure, and it will solidify into a single alloy.